All right, so today we are going to start by just reviewing all of our combinations that work for establishing triangle congruence. So first, just a reminder that a triangle is unique or rigid if only one triangle can be drawn from given information. So far, we've learned 5 methods for proving that triangles are congruent. So we have our first option right here, side, angle, side. So here we have 2 sides and the included angle are congruent. So that's essential. It has to be the angle that is sandwiched right in between those 2 marked sides. So I'm going to underline that word included, and that's why the A is right in between. Okay, SSS, we're linking up all 3 pairs of corresponding sides, like you can see. HL is really side-side angle, but for right triangles only. So we're linking up hypotenuse to hypotenuse and leg to leg. And again, we have to know that it's a right triangle. Okay, angle, side, angle. We have the 2 angles and the included side are congruent, which is why we put the S right there in the middle. It's sandwiched right in between these 2 angles here and here. There's that included pair of sides right here. Okay, and then over here, it really doesn't matter where that side is. If we know 2 angles, here, these sides here, they're the non-included sides. So with angle, angle, side, it can be 2 angles and a non-included pair of sides that make the triangles congruent. Okay, so again, those are the 5 methods that we've learned so far. We also talked about the 2 combinations that do not work. So angle, angle, angle. If we have 3 angles of one triangle and congruent to 3 angles of another triangle, the triangles are not necessarily congruent. So I could take this triangle, I could scale it up, I could shrink it down. There's really an infinite number of triangles that I could create with the same information. So angle, 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 again, does not work. Okay, side, side, angle is the other one that does not work. So that's when we have 2 sides and the non-included angle of a triangle. So let me do a little cross off, doesn't work. And that reason is right here where B is, that's our hinge, right? So we have our 2 sides and 1 angle. So the angle here, B, right in between the 2 known sides, right there, that serves as a pivot point, that's a hinge, where this side BC can swing back and forth into 2 very different positions. So again, does not make triangles that are necessarily congruent. It suffers from that swinging door effect. All right, so really quickly in example 1, is there enough information to determine whether the triangles are congruent by one of those 5 reasons? So side, 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 angle, side, HL, ASA, or AAS. Okay, so let's look at the first one. So in the first one, we have 1 pair of sides and 1 pair of angles. And is there anything else that we can link up? We should see right here that we have that shared side. So my reason for being able to mark that would be the reflexive property of congruence. And in doing so, I now have side, angle, side. So yes, they will be congruent, side, angle, side. And if I name the first one S, M, E, the second one has to be S, T, E. So remember that that order does matter. It really matters here. We want to sync them up so that all of their corresponding parts align. Okay, over here in B, I see those parallels, so I know I'm going to have to build off of them. So I like to emphasize those in bright red. And then my transversal here in blue. Okay, so now I can see that I have alternate interior angles that I can link up here and here. So the reason I can do that is the alternate interior angles theorem. Let me write that off to the side. Okay, and then I need to link up a pair of sides. I see that shared side right here. I'm going to give it a tick mark. Again, this would be the reflexive property of congruence. All right, so looking at my picture, I have two angles and a side, but it's not the side that's in between. Remember that the arrow means parallel, not congruent. So I have angle, angle, side. And if I name the first one SWO, the second one would be OLS. All right, next up. So here I'm seeing the parallels. So let me emphasize that again. Okay, if I make bright blue this transversal, I could link up my alternate interior angles here. If I look at my other transversal, I'll mark that in purple, I have a second pair of alternate interior angles right here. I could even link up my vertical angles here and here. So really I've connected my alternate interior angles. Let me write that. So alternate interior angles theorem. And then I even linked up my vertical angles too. So vertical angles theorem. But what I'm stuck with here is I don't have any information about sides. So technically, I could picture this same diagram looking dramatically different. Could look something like this instead, where I still have all of those angle relationships, all of those corresponding angles that are still congruent, but drawing it this way really emphasizes how they could be very dramatically different sizes. So what we end up saying here is that these are similar, but not congruent. They'll be the same shape, but they can be different sizes, so scaled up or scaled down. But knowing information about just the angles, it does not help. It does not establish congruence, so I cannot finish this statement, right? Because angle, angle, angle does not necessarily create congruent, rigid, unique triangles. All right, my last one here looks like an interesting diagram. I need to know which triangles I'm trying to connect. So this statement right here guides me to that. So CHR, CHR. So I'm looking at this one right here. So when I have these overlapping pieces, I often just separate them. So I'm going to go ahead and draw out CHR, kind of strip down. And then the triangle that I'm going to try to connect it to. So this one right here, where this is C, M, and A. Okay, and then I want to mark up all of the information. So from that first one, I have this tick mark here, and I have this angle right here with a single tick mark like that. For this triangle, I have this single tick mark side here, this angle, single tick mark right here. So I'm looking for one more connection. Can I connect a pair of sides or a pair of angles? And what I'm seeing is, well, for these two triangles, they have an angle that they share in common right here. Let me give that a double tick mark. So it's the same angle for both of those triangles. Let me draw it down here as well. And it's the same idea as up above when we have that shared side. Here we have a shared angle. So it's still the reflexive property. We're just looking at a shared angle this time instead of a shared side. So again, this is just reflexive property of congruence. Okay, and then looking at my picture, what combination do I have? right? I have two angles and I have the side that is sandwiched in between. So I have angle, side, angle. And if I name that first triangle CHR, so C to H to R, then I'm doing C to M to A. All right, so again, just a refresher of that first skill. Can we establish the triangles are congruent? If so, say why. Make sure that we're linking up in that proper order. All right, second page. Here we're going to practice writing those proofs. All right, so prove the triangles are congruent. Let me just get in a little bit tighter. Okay, and here are the 5 options that enable us to do so. So first up, we're told that SR bisects TM at point O. So this segment bisects this one at this point. So I know where that's going to build me. That's going to build me to this larger segment being split into 2 smaller parts. So let me start with that. So I'm going to say that SR bisects TM at point O, given. So again, that given built me to something else, right? It guided me to that this whole segment is split into 2 congruent parts. O is the location where this segment gets bisected. So now in step 2, I can say that TO is congruent to MO. Definition of bisect, right? That is what it means to bisect something, to split it into 2 smaller parts, 2 smaller congruent parts. All right, so now that's kind of a dead end, so I'm going to look at my other given. And my other given is that ST runs parallel to RM. Given. And I can show that with my little arrow notation for parallel. Okay, and then I can draw in those parallels. I like to light them up in bright red just to emphasize them. Okay, so now from here, let's say that I draw in one transversal. Let's say I draw in this one, and I have options, but I'm picking one. So if I draw in this one, then I can build off of those parallels to link up my alternate interior angles here. So I can say that angle T is congruent to angle M. Alternate interior angles theorem. Okay, from here I could go 2 places, right? My answers can vary. I don't have to do the same path as all of you. I could link up my other pair of alternate interior angles. That would be an option. I could also link up my vertical pair of angles. So again, we have choices here. I'm going to go vertical. But again, our answers can vary. So if I link up here to here, then I've linked up my vertical angle pair. So I can say that angle SOT is congruent to ROM. And this would be the vertical angles theorem. Okay, so now that I've linked up 2 pairs of corresponding angles and their included sides, I can reach my conclusion. So I can say in step 6 that triangle SOT is congruent to triangle ROM. I have angle, side, angle. Okay, but again, if I had linked up the other alternate interior angle pair, I could have used angle, angle, side, and that would be perfectly fine. We would be equally correct. We've just done it a different way. All right, next up in B. All right, so in my picture, I'm telling you that this triangle is isosceles. This is the base. This triangle is isosceles. This is the base. And we're trying to show that these two triangles here are congruent. Okay, so let's build off that first given. So triangle SKH is isosceles with base SH. Given. All right, so knowing that a triangle is isosceles, we know that that tells us that we have two pairs of sides congruent. I'm sorry, one pair of sides congruent. Sorry, two sides congruent, or one pair congruent. And then I have one pair of angles that are congruent as well. So here I'd probably, since I'm trying to connect these two triangles, I would use the sides here and here. So two sides congruent, or one pair of sides congruent. Let me phrase it like that. So now I can say that SK is congruent to HK. If a triangle is isosceles, then we have two sides congruent. Right? The angles just didn't help me here. Okay, now I'm at a dead end, so let me pick up the other given. The triangle RKA is isosceles with base RA. Given. So again, I'm looking at this triangle. How is that going to help me to know that that's isosceles? I'm trying to build to these two triangles being congruent. So I know, again, I have the two sides congruent, or two angles congruent, and it's the sides that are going to help me here. So I can say that RK is congruent to AK. So if a triangle is isosceles, then two sides are congruent. Okay, so I'm pretty close, but I'm trying to get to these two triangles here and here. So I need to either link up this pair of sides or this pair of angles. And those angles look pretty easy because they are vertical. So let me link up my vertical angle pair here and here. So I can say that angle SKR is congruent to angle HKA. And that's the vertical angles theorem. Okay, so now looking at all of my connections, I have two pairs of sides. I have one pair of included angles. I have side, angle, side. So triangle SKR is congruent to triangle HKA. SAS. All right, next up, looking at C. All right, so here first up, I have three givens. I'm given that SA runs parallel to PM. They are also congruent. And then we also have that point A is a midpoint of a larger segment. So let's say I start with the first two givens. I'm going to chunk those together. Remember that you can separate them or write them together. It really just depends on if you see the flow to something else. I see no harm in putting these together for this first one. All right, so SA is parallel to PM, also congruent. So arrows for parallel, tick marks for congruence. Okay, let me emphasize my parallels. Okay, I'm trying to prove these triangles congruent. So here is my transversal. Okay, so then I see right here and here that these corresponding angles are congruent. So I would go there next. That angle SAT is congruent to PMA. and that would be the corresponding angle's postulate. Right, we can see that that angle would slide into this position perfectly. All right, I'm at a dead end, so I'm going to pick up the other given. So right here, point A is a midpoint of segment TM. Okay, that is given to us. And if A is a midpoint, it is the middle point of this segment. So it's going to bisect it into two smaller parts, just like that. So I know then that TA is congruent to AM. And that's the definition of midpoint. Okay, so now looking at my diagram, I see that I have two pairs of sides linked up. I see a pair of included angles. So I have side angle side as my combination again. So triangle SAT is congruent to triangle PMA. SAS. All right, one last one. All right, so here again we have two givens. We're trying to prove that these two triangles are congruent. So let's start with that first given. So angle 1 is congruent to 2. Okay, and then I just mark my picture. So the issue is that angle 1 and 2, they are exterior angles. They're on the outside of our triangles. So we have to work our way inside. I want to link up 3 and 4. Whenever we see numbers in our picture, we know that we're going to use them somewhere in our proof. So what I need to do is I need to establish that, well, 1 and 3 are supplementary. They form a linear pair. So are 4 and 2. So I'm going to say angle 1 and 3 are supplementary, and so are 4 and 2. I know that because they form a linear pair. So this is the linear pair property. So if I know that 1 and 2 are congruent, these add to 180, so do these right here. Well, then I know that 3 and 4, they have to match too, right? They are supplements of congruent angles. So here in step 3, I can say that angle 3 is congruent to 4. This would be the congruent supplements theorem. Okay, so I have a pair of angles and they're inside of my picture. Okay, so I could build off of that, or I could look at the other given. Let me see what the other given tells me, and then I'll think about if I need to build off the 3 and 4. Because 3 and 4, knowing that these angles are congruent, I actually know that this is an isosceles triangle, so that could lead me then to these sides right here being congruent. So I know I have an option. I just want to look at what my given is first. So here I'm given that AS bisects RST. So I know that AS here bisects RST. Okay. I wrote the wrong notation. All right, AS, the segment, AS bisects angle RST. Okay, so the segment bisects the angle given. Let me show what that means. That means that this larger angle is split into two congruent parts. So that's going to lead me to angle RSA congruent to TSA Right? Definition of bisect. If we bisect an angle, it splits it into two congruent, smaller angles. All right, so now I have two pairs of corresponding angles that are congruent. I just need a pair of sides. So there's two places that I could build. What I'm seeing first is reflexive property right here because it's that shared side. But I could have also built off the fact that this is an isosceles triangle, and that could have connected me to this pair of sides as well. So I have really a couple options here. I'm going to go with what I saw with the reflexive property, that shared side. AS is congruent to itself. Okay, reflexive property of congruence. And then with the path that I've taken, with what I have marked in my picture, I have two angles and a non-included side. So I have angle, angle, side. If I had established that this is isosceles, and if it's isosceles, then I have two congruent sides, I could have had angle, side, angle, and that would have been fine. So in a lot of these proofs, we have some options. All right, so I'm able to reach my conclusion that triangle SRA is congruent to triangle STA, and the path I took is through angle, angle, side. All right, that's all I have for today. Have a good rest of your day.